Okay, in this video we want to find the general solution of this, and we can do that by first getting eigenvalues, then getting eigenvectors, and then we can conclude a general solution. So first we want to get the eigenvalues. So we say that this would be 1 minus r, and this would be negative 4 minus r, and these two terms remain the same. So let's write that down. So 1 minus r, so then we have 3 minus 2, then minus 4 minus r, and what we get by doing this will be so 1 minus r times negative 4 minus r minus parentheses 3 times negative 2. And so this would equal 0 actually. And so by doing this, we need to expand it a bit. So we would get 1 times negative 4 is negative 4. 1 times negative r is negative r. Then we have negative r times negative 4 would give us plus 4r. Negative r times negative r would give us r squared. Negative 3 times negative 2 would be plus 6 is equal to 0. And so now we would group this, and by grouping it we would get r squared, 4r minus r, so plus 3r. Then we have 6 minus 4, so plus 2 is equal to 0. And we can factor this out. So it would be r, because it's just r squared. If we say plus 2 plus 1, that would work. And so this would be r is equal to minus 1 or r is equal to minus 2. And these are our eigenvalues. And so now we want to get the eigenvectors. And so we will say, let me separate this out. We can say 4r is equal to minus 1. And what we had originally, and so we will plug in minus 1 for r here. So 1 minus minus 1 would give us 2. Minus 4 minus minus 1 would give us minus 3. And we simply plug it back in. And so let's write it down. So we said it was going to be 2, 3, minus 2, minus 3. And what we want to do is try to cancel out one of these terms using a row reduced echelon form. We can do that if we say that r2, this line right here, is equal to r2 minus 3/2 r1. So let me scroll down. And so this would equal, 2 would remain the same, minus 2 would remain the same, but this term right here would be canceled. We would get 0, 0. Further, we can reduce this by saying that r1 is equal to 1/2 r1. And so we would get 1, negative 1, 0, 0. And therefore, we could say v1, this term right here, is equal to minus parentheses minus v2. And so v1 is equal to v2. And so our eigenvector for this would be 1, 1. Because if we plug in v1 is 1, then v2 is also 1. Or if v2 is 1, then v1 is also 1. And so we say that this is an associated eigenvector for r is equal to minus 1. So this is one thing that we will later need for our general solution. And so next we will plug in r is equal to minus 2, because that was one of our eigenvalues, back into the original equation. So we're plugging in minus 2 for r, and what we're going to get by doing that will be 3, 3, minus 2, minus 2. And next we will do row reduced echelon form. And so if we say that r2 is equal to r2 minus r1, then what we're doing here is just canceling out this. So we would get 3 minus 2, 0, 0. And so we can therefore conclude that 3v1 is equal to minus parentheses minus 2v2. And so that would mean 3v1 is equal to 2v2. And so if v1 is going to be, let's say, 2, then that means v2 would be 3, because so 3 times 2 is 6. 6 divided by 2 would give us 3. Or you can think about it as this: v2 is 3. 2 times 3 is 6. 6 divided by 3 would be 2. And so we say that this is an associated eigenvector for r is equal to -2. And so now we will do the general solution. So let me write this down. General solution. And to do that, we have to go back to our two eigenvectors. And so let's do that. We will say the first eigenvector we had was this. So it was 1, 1 for r is equal to -1. And so that would mean we could say that C1 e raised to -t because the eigenvalue was -1 and the eigenvector was 1, 1, plus C2 e raised to -2t because the eigenvalue was -2 and the eigenvector was 2, 3. And so let's just box this in, and this is the final answer. And that's all we need to do for this problem.